Understanding the 5 basic types of welding joints, butt, corner, lap, T, and edge joints, is essential for welders, engineers, and industry professionals. These joints are the foundation of most welding projects and play a critical role in determining the structural integrity and performance of the final product. Each type of joint is designed to suit different applications, material types, and load requirements. Mastery of these joints enables professionals to choose the most appropriate one for any given project, ensuring strength, durability, and safety across various industries. Welding joints refer to the points or areas where 2 or more metal pieces are connected through welding. These joints are critical in various construction and manufacturing processes as they determine the structural integrity and strength of the final product. Different types of welding joints are used based on the materials involved, the load-bearing requirements, and the overall design of the structure. Selecting the correct welding joint is essential for ensuring optimal performance and safety. The right joint type enhances the strength of the weld, minimizes potential weak points, and ensures the longevity of the welded structure. Without proper selection, the joint could be prone to stress, fatigue, or failure, which could lead to costly repairs or safety hazards. Therefore, understanding the different types of welding joints and their applications is crucial for achieving reliable and efficient welds in various projects. 1. Butt joint. A butt joint is one of the most commonly used types of welding joints, where 2 pieces of metal are positioned end-to-end or edge-to-edge on the same plane and then welded along the seam. This joint is widely employed in various industries because it allows the welding of flat pieces, such as plates or pipes, without any additional preparation to the metal edges. Typical applications for butt joints include pipe welding, used in pipelines, gas lines, and other cylindrical structures. Structural fabrication, found in the construction of bridges, buildings, and other large-scale frameworks. Metalworking, applied in industries that require joining metal sheets, such as automotive manufacturing. Advantages: strength and stability. When properly welded, a butt joint provides excellent structural integrity. The weld can easily match the strength of the parent metal, making it suitable for load-bearing applications. Ease of access for welding. Butt joints are straightforward to prepare and access, allowing the welder to position their tools efficiently, ensuring a consistent and high-quality weld along the seam. Disadvantages: potential for stress concentration. The seam of a butt joint can become a stress point, especially if the welding is not done correctly. Over time, fatigue may occur, leading to potential failure under high loads or vibration. Need for precise alignment. Proper alignment of the 2 pieces is crucial in a butt joint. Even minor misalignments can lead to a weak weld, resulting in structural issues or the need for rework. 2. Corner joint. A corner joint is a type of welding joint where 2 pieces of metal meet at a right angle, typically forming an L shape. This joint is often used to create frames, boxes, and other structural shapes where a 90-degree connection is needed. In this configuration, the metals are welded along the corner where the edges meet. Typical applications for corner joints include box or frame construction, commonly found in creating metal frames, cabinets, and containers. Sheet metal fabrication, frequently used in industries such as automotive manufacturing and HVAC systems. Furniture and appliances, applied in the construction of metallic furniture or appliances with a frame-like structure. Advantages: simple to set up and weld. Corner joints are relatively easy to assemble and weld. The alignment of the pieces naturally creates the joint, making the welding process more straightforward. Good for creating a 90-degree angle. This joint is ideal for applications where a precise 90-degree angle is needed, providing solid structural integrity when properly welded. Disadvantages: difficulty in accessing inner weld areas. Welding along the inner corner can be challenging, especially in closed or tight spaces. Proper positioning and tool access are critical to ensure a uniform weld. May require additional support for strength. Depending on the thickness of the metal and the load it will bear, a corner joint might need additional support or reinforcement to prevent deformation or failure under stress. 3. Lap joint. A lap joint is formed when 2 pieces of metal overlap each other, and the overlapping edges are welded together. This type of joint is primarily used when the materials being welded have different thicknesses or when greater strength is required. The joint can be welded on one or both sides, depending on the strength and load requirements. Typical applications for lap joints include sheet metal work, commonly used in the automotive and aerospace industries to join thin metal sheets. Structural fabrication, used for joining materials of varying thicknesses in heavy-duty applications. Electrical component assembly. In electronics and small appliances, lap joints are utilized for connecting conductive metals. Advantages. Suitable for joining different metal thicknesses. Lap joints can easily accommodate materials of varying thicknesses, making them versatile in applications where uniform thickness isn't available. Provides a large welding area for a strong bond. The overlap of the materials increases the surface area available for welding, leading to a stronger bond and enhanced structural integrity. Disadvantages. Overlap can create a potential weak point. The overlapping section of the joint can become a point of weakness, particularly if the weld is not properly executed or if it experiences significant stress over time. May lead to increased material usage. Due to the overlap of the materials, more material is required for the joint compared to other types, potentially increasing the overall weight and cost of the project. Number 4. T-joint. A T-joint is created when one piece of metal is positioned perpendicular to another, forming a T-shape. The vertical piece is welded to the horizontal piece along the edge where the two meet. T-joints are often used when the vertical part must bear loads, or when two metal sections need to be joined at a 90-degree angle. Typical applications for T-joints include structural frameworks, common in the construction of frames and supports in buildings, bridges, and machinery. Reinforced connections, used in welding operations where a branch or reinforcing member is attached to a larger surface. Pipe and tubing connections, found in the plumbing and HVAC industries for joining pipes at right angles. Advantages. Provides strong load-bearing capacity. T-joints are ideal for supporting loads, making them suitable for structural applications where stability and strength are crucial. Easy to weld in various positions. The perpendicular arrangement makes it straightforward to weld in different positions, whether horizontal, vertical, or overhead. Disadvantages. Can create stress points at the joint. The intersection of the two metals can become a point of stress concentration, which may lead to cracking or failure under extreme loads or repeated stress cycles. May require additional filler material. Depending on the thickness of the materials, T-joints may need extra filler material to create a strong and durable weld, which can increase the complexity and cost of the welding process. 5. Edge joint. An edge joint is created when two pieces of metal are placed side by side so that their edges are parallel and the weld is applied along the adjoining edges. This type of joint is often used when the metal pieces need to be joined at their edges but will not bear heavy loads or stress. Edge joints are typically employed for parts that are thin and require minimal welding. Typical applications for edge joints include sheet metal fabrication, commonly used in industries such as automotive manufacturing and appliance production. Tanks and containers, applied in the construction of tanks, where the edges of metal sheets need to be sealed. Light metal fabrication, useful in non-load-bearing structures or for joining thin metal plates. Advantages. Ideal for thin materials, edge joints are particularly suitable for joining thin sheets of metal, which may not require a heavy-duty welding process. Minimal material waste. Since the metals are joined along their edges, there is very little material waste, making this joint efficient in terms of material usage. Disadvantages. Limited to thinner materials. This joint is not suitable for thick or load-bearing materials, as the weld along the edges alone may not provide enough strength for heavier applications. May not provide sufficient strength for heavy loads. Edge joints are typically weaker than other types of joints and are not recommended for applications where the joint will be subjected to significant stress or weight. In summary, understanding the 5 basic types of welding joints, butt, corner, lap, T, and edge joints, is essential for welders, engineers, and industry professionals. Each joint type serves a unique purpose, tailored to specific applications, material thicknesses, and load-bearing requirements. Selecting the correct welding joint ensures the strength, durability, and integrity of the weld, whether it's in the construction of pipelines, structural frameworks, or thin metal sheets. Furthermore, adherence to industry standards, such as those set by AWS, ISO, and ASME, guarantees consistent quality and safety across various welding projects.